The development of the motorcycle helmet happened by accident. In 1935, the British war hero known as Lawrence of Arabia died from a head injury in a motorcycle crash. He wasn't wearing a helmet. The tragedy moved one of his doctors to research the safety potential of motorcycle helmets. The motorcycle helmet is the most important part of the motorcyclist's safety gear. Today, wearing one is a rule of the road in many places around the world. Modern helmets are entirely synthetic. They design them on a computer. The software guides milling tools to produce a prototype from polyurethane foam. The prototype gives them a good look at the helmet's shape and style. Once they're satisfied with it, they build a metal mold for mass production. The molding material is a pile of polycarbonate pellets. It's the same thing used to make astronaut bubble helmets. An injection molding machine melts the pellets and injects them into the two-part helmet mold. The polycarbonate cools and solidifies into the shape of the mold. The result is the outer shell of the helmet, complete with holes for vents and other parts. Next, a robot grips the helmet shell and moves it against a sanding belt to smooth the seam left by the mold. The robot also gives the shell an overall polish. It then goes for a spin as sprayers coat it with black paint. A factory employee pulls a sheet of decals through water to lift them from the backing. She applies the decals to a white unpainted helmet. It's a flashier look than basic black. It takes practice to be able to apply the decals correctly because the helmet surface is complex and curvy. She smooths out air bubbles in preparation for the application of a protective clear coat. The next assembler installs a pivot mechanism on each side of the helmet. They'll enable the face shield and visor to be raised and lowered. The hardware fits perfectly into the molded niches. There's just enough room for the mechanisms to operate smoothly. She attaches the velour-lined chin strap with its quick-release mechanism to the outer shell. Then these foam polystyrene pellets are transformed into the helmet's cushioning inner shell. The pellets flow into another injection molding system. A nozzle injects the melted polystyrene into the mold and it takes the shape of shock-absorbing helmet liners. The foam solidifies and the machine ejects the completed liners. The density of the polystyrene foam varies throughout the helmet for strategic shock resistance, enabling it to meet international safety requirements. Padding in the crown and around the chin area makes it more comfortable to wear. They now join the helmet's inner shell to the outer one. After a liberal application of glue, she pushes the liner into the shell. It's a snug fit, and it takes a bit of maneuvering to get it in there. She attaches a robust chin guard to the helmet. This molded polycarbonate part is designed to protect the lower half of the rider's face. The assembler screws it to the helmet on both sides. With this part in place, the rider should be able to take it on the chin if necessary. A transparent polycarbonate face shield completes this motorcycle helmet. And now, a test. They drop a helmet from a height of over 3 meters to confirm it can take a fall without falling apart. It survives, and the entire production batch is approved. Designed for impact and made to specification, this helmet could just save your skull.